Hello and welcome, everybody. We're on our second session discussing an ontology tradecraft machine learning. We'll be discussing or talking more specifically about embeddings and using MOWL library today. But I had some other items to discuss, which I thought you might find of interest. In addition to leaving off with an overview of the next project, which I'm sure you're all itching to scratch because I know you're probably bored with all the other projects and you're just like what am I supposed to do in this class, John? Just sit here and listen to you talk or so all right, so more on that very shortly. Beforehand, I don't know if you've ever seen this phrase at the top, the Gostack, but you're about to learn about what that is in a second when I ask you the following question. When you see a sentence, how do you know what it means? I know this is a little philosophical, but I'm curious what you think. When you see a sentence, how do you know what it means?
Depends on context. Where you literally where you're reading it, you're reading it at work, school, home, that you filter it through your brain to figure out what the context is.
Mm-hmm. How about you go to the bathroom in a restaurant, you see a sign that says employees must wash hands. How do you know what it means? This is not to say you're wrong. You're right. I just
Yeah. So it means in a limited sense, it means that if you're an employee assumed to be of that restaurant
Mhm.
or that business, you have to wash your hands. If you're not, you can, but you don't have to.
Oh, I know. I know what the sentence means. I'm just curious, how do you know what it means? There's one answer for sure. Seems like it's in the right ballpark. It's a hard question, right? Like there's like a psychological aspect, it's like a linguistic and semantic aspect. There's also social aspect, but sociological aspect, probably a socioeconomic aspect. Language cuts across all of these areas and disciplines, so it makes sense that a lot of these areas and disciplines would have something to say about the answer to this. When you see a sentence, how do you know what it means? So let me ask you this. Can can you extract meanings from the shapes of terms even when you don't know what the terms themselves mean?
I want to say yes.
I would like to say yes as well. There's a tradition in the history of philosophy that said no, that syntax is so utterly divorced from semantics. It's the shapes of symbols can't give you the meanings or even give you any kind of insight into the meanings because there's such a broad divide between them. Now, I personally don't think that divide is that chasm is so deep. I think
Yeah, I think there's definitely nuance.
absolutely, and I think you can show this. I think you can show this by playing a game. This is an old school game.
Here is what you will see if you navigate to this space. Let's make it a little bigger. You should see, finally you are here. The Del Cloud Tandem, where Dosh is a div, but the Dosh reward is crammed with clouds. Clouds. How wrong it would be to tell back to the Buell and discount them. Discount the whole Delcon. Let the drugs discount them. But you are the Gostack, and the Gostack distems the Doshes and no cloud will whirl them from you. Copyright blah blah blah. Delcon. This is the Delcon Tandem where Ditch's Frank and Dust gets laid across from a costly purple, a Gomway div to kill off and Kurt. A Goming a Semilin to its Hoff. Crammed in the loft let are 5 clouds. And then you have a prompt symbol here, where you are able to type in things like, hello. That is now a date I recognize. You can type in other things like, what is a? That is also not a date I recognize. The name of the game here, partly figure out what the meanings, somewhat roughly speaking, of these terms are, so that you can perform certain actions in a standard dungeon crawl text editor custom. You'll notice here at the top that just as described here, this is the Delcot. You're in the Delcot.
There are 5 Glauds that you have and 1 Camlings. You know, in traditional games, you'd say things like move right in the dungeon, move left, open this box, do something to this Glaud, avoid a Camling. I don't know. I actually don't know what, I forget what the Camlings are or the Glauds. We get to ask questions and sort out what exactly the meaning of this sentences are. You might say things like distem the cloud. Oh, look at that. I distemmed a pultive cloud. What is a pultive cloud? I have no idea. All I know is that I just distemmed it. I think you probably see how the game works. Yeah. Like, play the game. Voral, the pultive. Wow, I'm pulling Voral from right up here. No cloud will Voral them for you, from you. I don't know what this means. Vorling is the fetch of calipers. Hmm.
I guess Google Translate is not an option.
It has a statistical, let's say, algorithm. So
Distinct of Voral. I can't rib any such thing. I don't actually think there's a statistical model behind this. Yeah. So I think this one's back in the day. It's 2000, what, 2001. Ancient times. Observe too that I've just done something and I have more camlings. Let's see. Rib any such thing. Boiling is the flesh of gallopers. Can I distem a galloper? Can't even reb it.
What can you wrap then?
I don't know. Let's see. Let's reb a cloud. The rascable cloud. Okay, so there's a rascable cloud. I just rebbed it. I reb it here. I assume I can disdunk the rascable cloud. I disdunked it. I just disdunked it.
And now you have 5 camlings
I have 5 camlings.
and 5 clouds.
Even. I distem the dotches. Can I distem the pultive cloud? That's already distem. Can I distem the rascable cloud? Oh, interesting. I can only distem pultive things. And now I've got 5 camlings.
6 camlings.
How warm it would be to pell back to the Buell and disdunk them. Disdunk the whole Delcott.
And if you pell back to the
Mm-hmm.
if you pell back
To the Buell.
to the wheel, what does it then say?
Let's see. Let's
Well, it says you got to distem more doshes.
I can't reb.
Oh.
Pell. Let's see. Pell to the, what is it? I'm Crandon Loft Lut. Pell to the Lut. So I'm assuming Pell means something like motion. What do you mean? The Kerflut, Jerflut, Loftlut, Hofflut, Kiloflut? Huh. Let's see. Pell to the Kerf. All right. You're on a Gomway Dievinghoff. Cool. Cool. With Gropples on the Fosk. Sweet. There's the strike across the Gomway here, and the Delcott is to Jerf. So I'm sussing out. I may or may not be right or wrong. I'm sussing out that Pell means moving. And maybe Kerf, Jerf means something like left, right. Off, loft. Maybe that's here, there. Or forward, up or down. I'm not sure. Seeing a repetition of a pattern.
since it's English cloud, there are some verbs. We can parse it in verbs, adjectives, and nouns for her.
there any other directions that I'm missing? Are there 8? Dude. You're on the Galway Deeping Hall. I'm assuming red means something like C. I can't see any such thing. So let's see, like rib the Galway. Can't see. Okay, rib. Oh. Okay, so maybe quality. Rapples on the Fosk, rib the Fosk. I can see the Fosk. Interesting. So my thought here is that I may have left the initial environment, and now as I've jerfed lut id or pelled to the jerf lut, I may have returned back to the Delcot where I started. So we've got pell to the jerf. Are you sure you want to pell at the top that curple? Yeah. Which I assume means no. Let me try again. Okay. You're top head and you can't reb. So if I'm correct about reb being seeing or something or sight, looks like I can't see anything. Let's test it out. What else can I tell? Interesting. Something has glaked me. I have been zanked. Da da da. I have zanked. I'm dead. I'm gone. Let's see. I could restore a saved Hallpock. Interesting. Undo my last Camling or quit. Ah. So what is a Camling?
That's but it's too dangerous to go outside alone. So we speaking like a guild.
Fair enough.
You get the first sentence.
The first sentence of the top.
Recognize.
I just said hello.
Yeah. The first one, distinct the cloud. Okay.
So the cloud. Yeah. Distinct the cloud. Oh, you mean the first the first command that makes sense.
Yeah.
1, 2. Greg just walked in. He's seen this before. He was like, "Oh no."
That's what we're doing today.
Just a little bit. Just a little bit. Not the whole time. Not even most of the time. But I will say I've just died, it looks like. I've been zanked.
Zanked.
Yeah. And I've learned information from this zanking. I can restore a saved Hallpock.
I remember there was like instructions like in there.
That's
and
true.
You get like 4 out of the 5 just by like I forgot exactly.
The help file. There is a help file. Absolutely is a help file. As a matter of fact. After you get through here, you can find the help file right here. This is a Hallpock. I assume that means help file. It is in the Gostek language, so it's always so helpful. But you're right, you can You can learn a lot about what you can do, yeah, because it provides examples. So for asking a child, you can blah, blah, blah. Yeah. So how do you find it? All I know is it's called the Hauppauge. The Hauppauge recognizes many other dapes. So these are just some example dapes, questions or commands. Try anything. If the Hauppauge looks a dape, I assume that means understand it. Maybe you can look it. Maybe you can as well. You know, only minimal help for this. Let's see what we got. Zank Gostak. Mike popped in Zank Gostak as a something. Zankage isn't the answer to this one, was the response, which is hilarious if it does mean kill. Like, don't kill yourself. So I know you want to play with that. Don't worry, I'll give you a little time later. But what's going on here? We don't know this language. We made some progress playing around, just posing dapes, you know, sussing it out. But what was really going on? Like, did we understand the language? And if so, what exactly were we understanding? The grammar seemed to be very similar to English. Like it seems like it had adjectives, adverbs, conjunctions, determiners, nouns, numbers, prepositions, pronouns, and verbs, standard kind of parts of speech. Even if we didn't know the meanings of the terms, we could learn a lot about how we expect terms to be structured. This game would be a little harder if it were in French grammar, right? Yeah. Some of the terms would be moved around a bit, but not impossibly hard. There's enough common grammar between English and French, right? Of course, if you had grammars that matched up or different languages, and there are examples of this game with grammars that aren't English, that are quite a bit more challenging for English speakers or just solo English speakers. But we're basically the point. You can get a lot out of just positions, like the arrangements of symbols and expectations about what arrangements of symbols mean. That shouldn't be new. It's not a dape I recognize. Some of the words in here are English as well. So, recognition. This game would be a lot harder if it didn't have any of that. So we're talking about embeddings today. There's a deep analogy here between what we're doing with machine learning and the kind of mining of structures that we'll be talking about today and that we'll be implementing in our pipeline. So roughly speaking, embedding is just a mapping from one structure to another that preserves features of interest. That's at a high level what embeddings are. And while playing the game, we're in a sense manually creating an embedding. And some of you in classes that I've taught have gone at lengths to manually create embeddings from the Gostak language into more familiar structures like English. Some of you have created dictionaries. I have some of you on video talking almost fluently in the Gostak language. I'm talking about you, Greg. The idea here being like providing a mapping so that you can observe that certain linguistic features were preserved, even if you didn't really know, say, what a haltive glob was. There are other linguistic features that were useful to preserve. Now, who has the time to do this manually? Obviously, not something we have the time to do. And yet, we do it. This is a paper I published on viruses, virus infectious disease ontology. And one of the examples I used was this paragraph, kind of a combination of a lot of text. This was done manually, where I was mapping over by hand, me and some interns mapping over by hand a lot of documents from the Lancet. The plan was to create a gold corpus that was using the suite of ontologies, some of which are referenced here, so that we could train models to do this kind of automated annotating for us. So some of what we did and some of what we were modeling was sort of handled for us by logic, right? So you see some ands, you see some determiners, you see some logic built in that we sort of get for free using OWL. And then you see a bunch of nouns and verbs and relations that we had to build semantic structures for. And we were throughout, assuming, I think reasonably so, to spend a lot of time working on this thing, that what we were modeling in the ontological structure actually did reflect the intended semantics of the paragraphs and the terms and relations and nouns and whatnot that were in those paragraphs. Now, of course, again, same question. Who has the time to do this manually? This is all in the interest of creating again, a goal corpus that you could use for training so we could predict these sorts of mappings, right? So we didn't have to do it. And it still is. Then we just go to the mapping. Like here. Then we actually have to get over into that mapping space. So underwriting a lot of contemporary technology around embeddings that we'll be using and others have used in machine learning environments is this distribution hypothesis that I think is worth taking very seriously because it both is partially the explanation for why the ML embedding work that we'll be focused on is so powerful, but also can tell you something deeply important about why ontology engineering in general is a discipline. A word is characterized by the company it keeps, where the company it keeps is spelled out in various ways, which we'll talk some about today. But the central idea is that words occur in a similar context. They tend to have similar meanings. So the doctor treated the patient. Doctors, hospitals, nurses, patients. The nurse assisted in surgery. Nurse, hospital, doctors, patients, etc. And you'll see fields have their own lexicon, so this shouldn't be an odd observation. In fact, it should be something that we're keenly aware of because fields have their own silos. So again, this observation is underlying a lot of machine learning through embeddings, but it's also partially the reason why we have jobs. I thought it'd be worth
walking through how you can build up these things before we get into a bit of a live demo. But we can talk about units of text, units of speech, whatever. Here we'll talk about text that you might be carving up and thinking about in terms of distribution and proximity to other parts or other units. You can think at the character level, right? Let's see, you can map expressions like B to numbers like 2, and then evaluate this new space that words like or phrases like be bad and have it with such a mapping. You see this is kind of the simplest embedding unit. You have characters assigns points in a vector space, for example, and you can do some kind of analysis to see how close these points are to other points. And you can kind of observe neighborhoods of points based on that embedding. These capture morphological patterns for the most part, like prefixes and suffixes and capitalizations. You can see just like a little point in space right here. A could be mapped in this three-dimensional space. Point. More interesting, I think, are words, like the sort we were playing with, where you see words given vector representations, and then similarity evaluated based on how close, or maybe the angles which their vectors have to other vectors. So you see man and woman embedded closer together than man and king or man and queen, although king and queen are closer together. This is basically what you're seeing here moving from left to right then is words represented, in this case, the 7-dimensional vectors, dropped into through reduction into a 2-dimensional space, and then similarity evaluated based on the proximity to one another in this 2-dimensional space. It's kind of the idea. And this general pattern, you'll see march through in all of these embedding strategies. Yeah.
So these numbers, like we have 7 blocks with numbers. That means like a 7-dimensional space, or okay.
Yeah. It's hard to visualize that, right? I'm not sure how to think in or see in 7-dimensional space. Thank God for algebra. I thank Descartes for whomever. But what we can do is think about this in 2-dimensional space. And we can play with various similarity metrics using stuff like cosine similarity, which we'll talk about actually later today, to identify proximity between vectors. And use that as kind of a heuristic for determining whether words means something similar to other words nearby. This is the idea, though. Representation in a dimensional space that's needed to characterize, like to kind of, roughly speaking, have enough space, algebraically or geometrically, to represent in some position in this field what you're trying to convey with a word like man, and then convert it into a dimensional space that we can run analysis on. And that's, again, kind of the central conceit of these embedding strategies. words aren't the only thing in grams, kind of the next level of sophistication. You see an N of 1 gram is just a word. This is a sentence. You see here at 2 gram, this is a sentence, which is basically carving out the sentences, overlapping, and then 3 grams and so forth and so on. Sentences too, you could do this at the level of sentences. Incidentally, you could populate this into a same vector diagram just as before. Same here, you just do it straight up with sentences.
So it uses different parsing in pretty slides instead of like parsing in the minimal level. It parses with 2 words at a time. Yeah, phrases. Yeah, because some phrases go together, right? Like, so you a lot of expect like Pizza Hut, right? Pizza Hut goes together. If you just say pizza, you're just saying hut. What am I talking about?
Nice. Alex has some experience with this.
2 perfect synonyms would have basically the same vector.
Yeah, we're going to see that. You should be, if you have synonyms, like perfect synonyms, you should be able to see the vectors pointing in the same direction or very closely to one another. We'll actually see something like that in a second. Missing from this list is logic. So you can, of course, think of logic in many ways, but here, it's worth pointing out, especially because we're playing with OWL. Like logical axioms, you can treat them as words, or you can treat them as n-grams, and you can treat them as sentences even. There's certainly a special type of sentences that capture entailments that we want to preserve. So there's a sense in which OWL axiomization is just kind of a species of the sentences, this kind of sentence strategy, but that's not quite right, because it's not exactly just measuring similarity in the traditional sense. I want to highlight the difference between the traditional methods and the OWL, the MOWL-based methods more clearly today while working through an example. But I did want you to also see how you can build these kind of vector embeddings up from the smallest piece to larger pieces, like from characters all the way to sentences. Pull that analogy that I mentioned earlier together, though. So when we're playing a Gauss stack, we're pulling meanings from surrounding words. We're doing word embeddings, same. We're just encoding them in nearby vectors. Context defines roles, or the meanings are like the kind of parts of speech. Same. Context windows define embeddings. And then players can learn categories. On the one hand, models learn structures on the other. There are no explicit labels in the Gauss stack. Well, it's not exactly true. There's some, but not many explicit labels in word embedding. It's more or less unsupervised learning. If you were so inclined and had nothing to do on a Sunday, you could in fact train a little distributional model on made-up data from the Gauss stack. Yeah, and it can learn relational structures and have meaning emerge through this co-occurrence of vectors, right? So here's I didn't use MOWL for this. I'm just using word2vec. I'm importing it, and I just am looking for words that are most similar to Gauss stack based on this based on this sentence list that I gave it. So the list of sentences, I gave it 1 sentence, 2 sentence, 3 sentence, 4, ran the analysis. You can see Gauss stack appears most often near distems and dashes, so they end up closer in the embedding space. So given this minimal distribution, or these minimal set of sentences that I gave it, this is what it concludes.
Maybe the sentence like 4 lines, so it's not enough to.
Absolutely. You probably don't want to think take this, like you wouldn't want to take this and be like, I'm going to go figure out the Gauss stack now. You need a lot more data. Yeah, right. That's right. Also, these are low scores from anyway. But you can see, like in this sentence distribution, distems is closest to Gauss stack, and you see exactly where that's going on. There's nothing there, but you did the comparison, you should be able to get similar results. Now, I want to give you the opportunity because I know some of you probably want to go play that game some more. If you are interested, go forth. I'll give you a few minutes. I know when I usually bring it up, people are very keen on continuing to play, even though I tell them not to, but I don't want to fight your urge. If you you want to play Gostak, play Gostak. I'll give you a few minutes, but then I'm going to get back over into the lab demo. You'll see here that I say live demo. More like I'm alive and there'll be a demo. Like semi-live demo. So, but here before this, I do have another exercise for you, and this will be in anticipation of our next project because you'll be doing something along these lines for part of it. But I would like for you to navigate to the artifact ontology of CCO. I would like for you to open it in Protege, and I'll drop this link here so you have it in the chat. You just go straight there. I want you to open this in Protege, and I want you to identify 5 classes that seem underspecified. And then I want you to write one hypothesis each about how each might be better specified. For example, if you're looking at the class sensor, you might be thinking, it'd be really cool if this had an OWL axiom connecting it to a sensor function, stuff like that. It actually shouldn't be that challenging to provide examples of these hypotheses because CCO is so underspecified. But go forth and do this, and then we will share what we came up with. And I will say this. I'd be really keen on seeing something more sophisticated than this example. And you might, to get a handle on that, inspect the textual definition of various classes and say, well, what's here? What can I pull out that's not in an OWL axiom? Some of them are a little, quite logically tricky. Some of them are not. But you get extra points for the more sophisticated ones, for what that's worth. Much like whose line is it anyway? The points might be made up and not matter. So in the interest of not just having you sit here and stare at me, I will also do the same. If you're looking for what to identify that's peculiar to the artifact ontology, it should be in bold, like artifact design, for example.
So we should look for possible axioms.
That is correct. Yeah. You'll see that it inherits some from BFO, and you'll find the axioms that it has over here under description. If you're assuming your windows are set up like this or like mine, which is the default, you'll see, these that are not bold. These will be inherited from BFO for the most, or at part of some other module. So like the information content entity prescribing some entity. If I'm not mistaken, that is an axiom that you'll find in the information artifact ontology and not in the artifact ontology itself. These in bold, though, are peculiar specific to this artifact ontology file. For our purposes, if you see an axiom down there, I'm looking for more.
So Protege does not like me. I see one class. I don't see a whole bunch of stuff from the artifact ontology. This
Interesting.
is
Do you want to
something's
share
wrong
your
with the
screen?
import.
You want to share your screen? We'll debug it.
Sure, why not?
Need to do that.
Oops, let me get rid of some of my other junk.
Right. I had to do that earlier. I was like, I'm gonna share my whole screen, but make sure my bank account information up here or something. All right.
So you can see here, I have protege up. You can see I have resource from the artifact ontology. And that's about all that shows up. Or artifact history shows up as well.
Can you let's see, can you go to just go to the top. Are you on a Mac or PC?
PC.
Can you go to the what is it, OWL thing? At the very top. Or entity. Can you just click on entity and highlight it there? Can you close everything under entity? Okay. Now on a Mac, if I hold Option and then click it, everything opens up. I think it might be something like there's one of those keys down there. If you'll hold it and then click it, everything, like the whole thing will expand, whole hierarchy. All right.
It's Alt.
There we go. So you see
Alt
the
click.
items in bold down here, like artifact identifier. All right, so the ones in bold those are all peculiar to this ontology file, and those are the ones.
Okay, I'm seeing it now. Got it.
We're, okay. I'm gonna go ahead and switch over.
Yep.
Okay. Switch this back over here. So hopefully you guys can see my screen now. Yep. Okay, so you see, CCO is under axiomatized. So certainly, if you're comparing the richer axiomatization space for BFO, down here at the bottom, what you see that's not bolded, it inherits a lot from the parent classes, artifact location. But a lot of there's some logic that's built into the textual definitions. Some of them line up pretty closely with the OWL axioms that exist. Others don't. So a site is the location of some artifact. This is stated as equivalent to a site and bears this location of relationship to some instance of material artifact. Know how this is read, because this is a class level constraint. So that means anything that is an artifact location is such that it's a site and it's the location of some material artifact. So there has to be, for any artifact location, some material artifact. That is a logical relationship. As you're exploring these, you may find some of these constraints that do exist and not maybe be susceptible to counterexamples. Not saying this one is. Where am I? What I am saying is it's worth scrutinizing. Okay.
Can you go back really quick, John? I got like 2 minutes before a work meeting starts. But so you said 5 classes and that are underspecified and the axioms associated that seem underspecified.
Yeah,
How
plan
much might
here.
be? Okay.
Identify 5 classes that seem underspecified. And by that, I mean underspecified with respect to their OWL axiomatization. I think there's another question about whether the OWL axiomatization they have is appropriate. I consider that kind of, also within in scope here. But the easier case is thinking about the ones that just are missing axioms insofar as you like infer axioms that should exist from the textual definitions. And you will find many of those.
Okay. Got it.
For example, a radio repeater, transceiver that is designed to receive radio signal, a radio signal, amplify and retransmit it, often on another frequency. So you see the axiomatization it has, it's just listed as a subclass of radio transceiver. It is not inheriting anything from radio transceiver because there are no axioms for it to inherit. What it is inheriting are axioms from BFO, namely the continuate parthood mereology and disjointness. So you might think, since this is saying something like a this class radio repeater is a transceiver that is designed to receive a radio signal, there should be some characterization in the OWL of design, some relationship to receipt of radio signal, amplification, retransmission, etc. I'll note too, as a kind of a rule of thumb that might help you, there's a convention in the CCO modeling that if you're reading a textual definition and you see a noun that is not capitalized, it means that that noun does not have a representative class in the ontology. On the other hand, if it is capitalized, there should be a class for that noun in the ontology. So like radio receiver, there's a class for that right there.
Hmm.
Here's a good one. Container.
John, quick question.
Sure.
The word designed is used often. Isn't that just sort of has the function? I mean, the function sort of implies it being designed that way now.
Designed is a wiggle word that's used in these definitions. It's used a lot. It's because what's going on in the characterization of the definition of like container, for example, is we folks developing it wanted to allow for broken things, like things that don't always serve the purpose or function or have the say dispositions that they like we would typically associate with them. This was in the interest of making them more flexible. I wouldn't exactly want to say design always in these textual definitions tracks function though, because there are some information-y things that are described as being designed. And so while they might, loosely speaking, be said to have a function, it's not the BFO function sense, not immediately or not obviously. Even so, though, you're certainly picking up on probably both the wiggly aspect of it as well as this thing was created for this purpose. There's another strategy that's employed, I think, more often in the biomedical context, which is classes are typically used in textual definitions to be picking out canonical entities. And so instead of saying something like a container is designed to blah, 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 you would just have implicit that a container, as you're describing here, is the canonical container, right? And so the design is less important than what it actually does, because the canonical thing does the thing it's supposed to do, and we're not worried about broken cases. CCO took the kind of more flexible route. The canonical strategy, you can often derive, you have to do a little more work in creating like what it means to deviate, but they usually use the canonical as a base case and then provide the deviations with respect to that.
Thanks.
Hey, John, quick question. What do you do? I'm assuming like we'll go into the field and we're probably going to run into, some definitions that are probably not great in terms of like representing what they are. Like say for, I don't know, like telephone line or something like that. telecommunication network line that consists of a physical wire and some other signal medium and so on and so forth. But say when we're making like the equivalent to class, like, okay, well, telephone line is equivalent to a telecommunication network line that has some function. And I'm just like spitballing here, but like, how would you manage like doing that? Because that takes time, as you're doing that for everything that you're doing with or you're working with. How do you like balance that line of like going down this rabbit hole of trying to make all these equivalent to classes to fix everything, and then just producing what you have to do?
Yeah, I'll tell you, in the traditional strategy is to just do it anyway, like regardless of how much time, just do it and hope for the best. Go in and like we train modelers like yourself to go and do the hard labor of like thinking carefully about what exactly the axioms will be for this. So telecommunications network line, you want to create an equivalence class for this. What is it? Okay, so consist of physical wire or other signaling medium. How would John Beverly do this? Well, it has some heart-hood relationships associated that are connecting, whatever the instances of this class are to physical wires for sure, some physical wires, perhaps more than one. Have an option for other signaling medium. How would I handle that? Probably not an assertion at the class level, but probably an assertion in like a swirl rule or some trigger based on certain context that allowed me to give options. So whenever I encountered this sort of thing, I would trigger the addition of certain triples to my database when I needed them. Then I'd get into the part about the design to be a part of a telephone network. I would spell out in more detail what design was. I'd probably actually pull design out of this definition. I'd leave design on the information side as it's prescribing things. And this would be the sort of thing that, if accurately created, would be thing that was prescribed by some design. And then I would have it as a mereological part of a telephone network going forward and spelling that thing out with mereology itself. Now, that would take me some time. I'd have to draw some pictures and have to assert a bunch of axioms. Now, I don't want you to do that. Part of today is showing you how to get around that. And project 5 is certainly going to be showing you how to leverage existing tools from machine learning community to avoid that. So what we're doing now is getting a handle on some of the gaps. I want you to get a feel for the textual definition structure. I want you to get a feel for some of the mismatch between the textual definitions and the MOWL axioms and the artifact ontology. Because in project 5, I'm going to have you extract using MOWL what you can from the textual definitions so that you don't have to go through this and do it manually or even talk to it like I was just doing. There's still going to be cases where you're going to need some expert insight, but we want to narrow down those. We want to get all the stuff we can do with MOWL out of the way first so we can focus on the harder questions.
Got
So,
it. That makes sense. Thank
yeah,
you.
so just do the exercise here in a sterile environment and then do the project so that you never have to do it again. Does anybody have anything they want to share? Any gaps?
But my main concern was just like they're using in their definitions relationships that are forbidden by BFO.
So tell me where the forbiddenness is coming from.
An object track point that is where a vehicle is or was located, and a vehicle is an independent continuum, and it's saying that a vehicle is or was located in an object track point, but located in says that the domain, the range of located in is independent continuum, but not spatial region.
Yeah, you certainly, if you put an axiom that had located in, you get a contradiction. If you linked it between the object track point and like the vehicle. Here's what I'm going to do. I put in vehicle. I'll put an object track point. I'm going to make this a class of object track point. I guess that's the class of vehicle. I'm gonna say under property. All right. So this should generate a contradiction. So I've got this object trap point instance, subclass object trap point, vehicle, subclass of vehicle, or a type of vehicle, asserted the location of, saying that the vehicles or object track point is the location of, I think, not implausibly related to the textual definition. Let's see what happens. Inconsistent, as expected. It's for the reasons that you described. It'll tell me why. I'll tell it to stop searching, just show me. It's basically going to generate several proofs circling around the reason you identified. This location of domain and range. All right, that's a good one. What else we got?
The second one was just about when you look down the entire list of all the subclasses of material artifacts, all their textual definitions start off with a material artifact that is designed.
Mm-hmm.
When you look at BFO, I'm pretty sure like in the definitions of the classes, whenever you assert a subclass using like a differentia of a relationship, like you say, this is a subclass of this because it's related to something in some way, that relation is also defined BFO, but in material artifacts in CCO, there's no definition of what it means to be designed anywhere.
That's right. We have this artifact design. So directive information content entity. So dice of that sort, all the sorts of things that do the prescribing. And so when you're thinking about designing something, this is where the head goes. Specifications of objects, these artifact designs are that manifest by some agent intended to accomplish goals, blah, 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 satisfy requirements subject to constraints. This, I can tell you, these are the sorts of things that we're supposed to be linking up to what's being designed. Like, so there's supposed to be a connection between them. You have models that fall under here. You have different types of specification.
What they're doing in the textual definitions, because I guess instead of writing material entity that was prescribed by some designated ICE, they would just write design instead, because it's just like an easier way to write it.
Well, there are a couple of reasons. One is they wanted more flexibility when they were dealing with artifacts than using just a canonical example would give them. So CCO was developed without a lot of axioms on purpose for flexibility. And so that made its way both into its lack of axioms, into the definitions. They noticed it'd be very easy to come up with counterexamples of material artifacts when you're just kind of describing the state. And so you'll see, I mean, it's not hard to come up with an example, right? Just a fan. Fluid control artifact consists of a rotating arrangement of vanes or blades that are designed to act on a portion of fluid to create flow within it. So why the design constraint there? Well, is a fan that's not rotating still a fan? Yeah, if it's not like actually, it could, it's just not, right? You can see this come back, like this is a particularly good example too, because you'll note that design is modifying active portion, blah, blah, blah. But there is some kind of assertions about the nature of the thing prior to the design clause. So it's a fluid control artifact that consists of a rotating arrangement of vanes or blades. Are there examples of fans that are fluid control artifacts that aren't consisting of rotating arrangements of vanes or blades? Take the rotating part first, because that conflicts with designs. Yeah. We wouldn't want to use that with fluid control, but there are other types, of blades, really. There's one, that's one. And then the other side, this says rotating arrangement. If what I said about the, example of a fan that's not on holds, there's that rotating constraint is outside the design modifier, which means that there are plenty of counterexamples to this, both in terms of the types of blades and also in terms of whether it's on or off. So not a great definition. But anyway, to back to the point. So the design, like that kind of design qualifies what I was saying a minute ago. It's a bit of a wiggly word. They had to move quickly, they had to define a lot of terms, and they had to do that, for sponsor needs and whatnot. And so they found themselves getting into potential counterexamples, and so they didn't have time to think too carefully about some of the definitions, and they started using as a rule of thumb this design qualification because it's flexible. Now, ultimately, it's supposed to be spelled out in some terms of some kind of prescription that connects it. So there's like an implicit bigger model, and also a bigger model that's connected up to functions, as was described earlier. If you note, you just go up to material artifact, material entities. All of these are designed by some agent to realize a certain function, right? So it's right there at the top, and they're all supposed to inherit that. Again, just to contrast, there is the kind of another strategy you could take, which is taking a canonical model of like a fan and say a canonical model of a fan is the sort of thing that, may or may not be on, but if it's on, it's going to have rotating blades or vanes or something like that. It doesn't mean all fans fall under that. It just means that canonical fans fall under that. Just like a canonical human has 2 arms, 2 eyes. Doesn't mean all humans. It doesn't mean if you lose an eye, you're not a human, right? But you can describe what it is to be a human without an eye or missing an eye. Nonetheless, you wouldn't fall into that categorical model. Doesn't mean you're not human. Does that make sense? You'll see those kind of wiggly words throughout.
So we still have resource as a class in CCO, right?
Yeah.
Okay, so it is a weird. I don't want to say it's a weird class because it's
It is.
outside of everything. It's still a continuous.
Mm-hmm.
And everything can be a resource given the definition, but it doesn't have axioms. It says that it's basically something that is owned by an agent. We have the agent ontology. We don't have the owning or possessing relation. I have checked the agent ontology. Maybe there is another one, but we can just add resource as a subclass of owns by an agent, owning or possessing or something like that.
Yeah, this is something that I would typically, like this in particular, was a class that I would just jettison. I think
Or we could just read of it.
it's not great. Yeah.
At the object property owning.
Yeah, I mean, and we could spell it out. I think if you start to spell it out, it will fall naturally into some subclass more than just continue it. But I mean, this is all role talk, like owned by, possession of, controlled by, role talk, plan talk, like, and then, yeah. What are the examples they give? Like a software program. So without going too much on a pedestal, my understanding of the use of resource from Kubrick and from the folks using this is that there was, I think, I hesitate to say confusion, but maybe like an overlooking of the fact that as ontology engineers, we're not exactly beholden to specific word usage like resource. So there is a sense of resource that absolutely is used when you're talking about a software program. Absolutely a sense that's used when you're talking about a sum of money or a vehicle or plot of land. Of course, I get it. We're modeling a deeper structure than language. We can derive the kind of deeper structure, or we can derive talk of like a software program as a resource with like annotations. So do we need a single class resource that groups all these together? Or do you just need if you want all the resources, do you just need to write a Sparkle query that pulls back all the annotations and have an alt label that said resource? I tend to go for that because I like to represent in my ontology the kind of fundamental structure on which everything else is derived. But, you know, who am I?
You know, building terminologies are one voice in the bunch and not the most important one.
That's right. We're definitely doing something different. And not to say that other groups aren't doing something important. It's just that we're doing something different and also important. And it's important to keep those lines.
The MOWL will suggest you, given the textual definition and maybe some similarities, hey, just add this accent that I just suggested. But actually, we have to review the previous class. And
that's a very good observation. Yeah, absolutely. So you're going to be using MOWL on this ontology. And you're going to have to keep an eye out for things like what Fede is talking about here. So some of the input you're going to get are going to help you generate predictions for axioms, and you'll need to tinker and figure out when the axioms should be added, when they shouldn't. You'll have to think a bit about your training set, to think about your validation, your threshold, stuff like that. And you may need to just trim up some of CCO, honestly.
Is the training set the CCO now? It's not perfect.
That's right. It's not training set's not perfect. And what do we say? Garbage in, garbage out. Let me then pop open the next section. So I feel like we spend enough time talking about that. Let me now go back to the lecture. So, all right, I'm sure you have plenty. I'm sure it was not too challenging. You'll have an opportunity to do more of this in the project too, because I want you to kind of look at some of these axioms and see which ones are worth training on and which ones not. But today I want to highlight though training, validation, and testing ideas. So I did discuss training last time and hopefully had you guys set up your MOWL environment, or at least, download what you needed to. Today, I'm going to illustrate these ideas not with MOWL, but with Word2Vec, right in the kind of theme of what I was doing or what I was describing earlier. And that's mostly because it's just easier to work with MOWL. But it also will be an opportunity to highlight the difference between MOWL and traditional strategies for training using machine learning, which often use things like Word2Vec. That said, the script, and you'll see this more clearly, the script I'm using here knows nothing about OWL semantics. And so when I feed it in the artifact ontology, it just treats it like a plain graph. So it doesn't embed the logic. It just treats the patterns as patterns of the same sort. Nothing special about the patterns that it sees. Just like with a corpus of text, nothing special. It's just plain. So it's learning patterns that it can see, basically frequency and similarity. I'm going to do it in this space, Google Colab. If you have a Google account, you can pop it open too. If you've not seen this, you should play around with it. It's a little environment, little places you can plug code in and let it run. It's got a lot of packages that you need to run with Word2Vec. It has some packages a lot of packages you need to run with MOWL. It'll automatically download whatever it needs to run your scripts when you poke it in. Looks like this. Should look similar, especially given your familiarity now with Notebook, Jupyter, right? You got the PI or PY and B at the top. But you can navigate here and play at your leisure. I'm going to be running a code that looks like this. I've put it up don't worry, I'm going to pull it up in my browser in a second, but you can see it too here at the bottom. I'll drop a link because I posted this last night. If you want to follow along.
Here's slides on project 5.
Yep, I'm gonna end on project 5 today. I'll describe it, but so basically, and at this point, let me just pull up my collab environment. So yeah, exactly what I was showing a minute ago. So you just paste your code, this code. I'm going to tell you what it's doing in a second, but it's a bit lengthy, but there's some descriptors in here. I'm going to run it. You'll see something like this. You just post your code in, run. It'll try to download or whatever it needs to run the scripts. So it'll take from the top. You've got your imports. It's going to try to either it has what you need or it'll try to add what you need. Dum, dum, dum. So you had to download some stuff. Make it work. Boom, 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 boom. And what this is going to do is going to run training, testing, validation, and it's going to pull together some similarity metrics. Again, I'm going to talk about this in just a second. Just want you to see the output first. Running over the artifact ontology, and then it's going to plot a diagram. I'm going to show you a distribution of clusters that look like that. You'll see I've given some lab demo reports, similarity metrics, mean, cosine, blah, blah, blah. Again, I'll describe that in a second, as well as some nearest neighbors for sanity checking. But note here at the top, I am just pulling directly from the artifact ontology straight off the GitHub. And I got some admittedly weird results that I will describe now.
But is it getting the positions in the vector space from like embedding the textual definitions?
Let's find out. What is it doing? So not quite, but that's something you'll be doing. So now, not quite though. For this, what it does is it extracts classes, labels, and RDFS subclass relationships from the artifact ontology. And so it's basically saying every time you see some class, subclass of another, remember that as some connection. And then it builds two lists. One is a class of all, or a list of all the classes, and the other is all the relationships. So you get classes and edges, or nodes are connected to one another, and then the nodes are classes, and they're connected through this subclass of relationship. Before we start learning, so after it's done this conversion, before we start learning, we split the edges. So the edges, we split them into training, validation, test cases. And that split is like 80-10-10. So it's 80%, 10%, 10%. It's the standard. The training is what the computer can see. Running that through what the loops are going over. Validation, this checks the quality of the outputs. And then testing is to see if we can guess new relationships. So we do this, we have to, here's part of the trick, and one of the reasons I wanted to demonstrate this example. We have to do this really carefully when we're thinking about subclass relationships. You'll also need to do it carefully with an under-axiomatized ontology like CCO's artifact ontology, because as you're removing edges for the training and test, you can isolate nodes. So you have to be kind of careful about not isolating nodes, because if you have like material, well, if you have leaf classes just dangling around in your validation set or your test set, I mean, you're not really identifying those things as related or nearby to other classes because there are no connections. So we have to be kind of careful about, say, not cutting off the bottom of the tree. Otherwise, some classes will just be floating in space and never visited, and the computer couldn't learn about them. What do I mean by not visited? All right. So there's some we're generating a corpus here, a corpus of training, or corpus for our training based on this directed graph. And we're using this random, like a random walk through the graph. So you're essentially starting at a random class, and then each step you're just kind of tracking down links and sublinks and whatnot, subclass of, superclass of, for about 20 hops. And you'll get links like laser, optical instrument, measurement device, artifact function, and so forth. And then we're doing this like thousands of times, so we have a kind of bigger test set. Now, if you're thinking about what I said a minute ago about just kind of cutting off and isolating classes, if we've pulled out, leaves or like small branches from our ontology and put them in a training set, And like maybe if I cut something from the middle of the graph out, for example, and like now I've got like this kind of hierarchy that's not connected to other hierarchies. And I'm running my random walk. There are going to be some clusters. I'm going to have a sub hierarchy, some random walks across that, a bigger hierarchy, random walks across that, no connections between them because I pulled out something that connected them. Does that make sense?
So mathematically, you have to check before you start training that every of these three parts of the split they have the mathematical structure of a tree.
Yeah, you basically want to make sure that you're not like creating gaps.
But not just a tree, of course, because
Not
there
yet.
are also properties.
Yes, yes. Although I didn't use them for this. You'll see though. That's the next step. But just here, I'm trying to illustrate just the kind of some of the core features. Random walking, generating a corpus of random walks, and then also being careful about what you're pulling out from the graph because you don't want to isolate things. This is especially true when you're dealing with sparsely axiomatized ontologies with MOWL, because it's easy in your test set to pull out something that just isolates a bunch of the graph or bisects the graph. So from these walks, like, why do we need all these walks? Why? Why am I generating this corpus? From these walks, we count how often each pair of classes co-occurs in the same walk, so the kind of proximity to one another. And we're giving weights to like close relationships, like direct subclass of, and then we do it, we up to 3 hops. So we're like prioritizing things that are within 3 hops from one another. We're like prioritizing those. We're saying these are more important than the others. And from that, we're generating a giant table called a co-occurrence matrix. This is not the co-occurrence matrix of the artifact ontology, but I thought I'd give you an example of a co-occurrence matrix just to illustrate. It's a big ass table, basically, of an incidence matrix that looks something like this.
Okay, randomization. You use it because you could basically run the walks to have like a complete walk of everything in which you have the real number of the pairs and how strongly they're related. You don't do that because that's costly, I guess. But
sure,
like in theory it's possible. And then random because it's random sampling, so it's like, well, it's enough for the general distribution.
That's right. And if we only let's say we had that, right? And maybe we do, right? Let's say let's say we just have that. It won't help us so much for prediction, like new links. We'll have what we have, like, and like this is all of the links that we have. Like what we want to be able to do is like take out some links and test whether our model can predict the links that should be there so that we can trust it when we encounter or when we need to generate new links that maybe aren't already in the set. So there's a sense in which like we want kind of a lot of training data. We want like many walks so we can train our model. But also not just the whole thing, because we have what we have and we're trying to do something a little broader than we want to introduce a little induction to this. Now, at the same time, when we get to the validation step, and we're thinking about particular similarity, we don't just, for the same reason I'm describing here, we don't just want to kind of talk about the similarities of vectors just based on whether they match 100% or not. We need some kind of threshold criteria for prediction that tells us like above this threshold that we can trust that there should be some new link here. We'll talk about that in just a second, but these things are intimately connected. But leading into that though, validation, when you have a class such as A and B and they're in the training set, and you have triples that like A already have a subclass of B that are not held back in the validation set, what we want to ask is a question like this: given what the model knows about A and B, do they look like subclass pairs? So we want to be able to validate against that. Using what we trained, we use this kind of similarity strategy, very common. Fundamental. If you're familiar at all with matrices, it's basically like what I was showing you earlier with man and woman and king and queen. You like the angle between them. Like you got a vector pointing this way, vector pointing that way. Closer is more similar, farther is less similar. Kind of all you need. So more in with some numbers, the angles between vectors. If you have vectors that have a 1 between them, like this 100%, basically, you can think of it like that. They're essentially pointing the same direction, the same vector, very similar, perhaps identical. If they're in the opposite directions of one another, very dissimilar. 0, just kind of not related. So you could have like contrasting terms versus unrelated terms, and everywhere in between. For example, if you have a function that's calling code laser an optical instrument, it returns like 0.95, very close to 1, then the model thinks they live in the same direction in the vector space, i.e. they're very similar. If it's 0 negative, they're far apart.
Are we doing something similar to the NLP n-grams? No, we have the pairing.
Not for this, but you will. Yeah.
Well, does that mean like because it's a very high reading that laser and the optical instrument are in the same tree, meaning that either they'll have like a common parent class or one of them in that pair is like the parent class of one another?
That's right, based on the tree. So you can see, pick this example on purpose. Laser optical instrument. So we collect those similarity scores from these pairings, and then we compute a mean and the percentiles of them. This is where we start getting into the threshold, where we're like, why do we have, okay, so first we have like this corpus of walks. Now we have similarity scores between the pairs, and now we want to calculate the means and percentiles associated with them. So we pick some thresholds, usually not arbitrary, like 60th percentile, such that if the cosine similarity is greater than that, we consider it there to be a predicted subclass link. So, and these percentiles help us see what counts as a typical similarity for real subclass pairs. If we just picked whatever we wanted, I mean, it can be arbitrary. We need a rule that tells us when the model is confident enough to predict the subclass relation. So, for example, if you pick something like a threshold of 60th percentile, what this means is if the cosine similarity between two classes is higher than what 60% of the real subclass pairs had, we'll count that as a predicted link. So, for example, suppose the 60th percentile is cosine similarity of 70, so the angle. Then the threshold of 70 means that if cosine similarity for some novel pair is above 70, then the model predicts there's a subclass relationship there. And if it's not, if it's below, then the model does not predict that.
How does it know order? Like how would it know in a given pair which has like a high similarity, which class is the subclass of the other one? Like would it matter? Like would one pairing have a higher percentage given one order of
Well, first, one question back to you. Do you think, if we're thinking about what I've been saying, is there a need to have ordering?
Not necessarily.
There's just proximity, right? Yeah. Now, I think once we think about ordering, to get into like imposing kind of structure in the training, right? Now we're going to get closer to that MOWL space. So as we start imposing that, it'd be very interesting to see what the training looks like, what the thresholds look like, and also what the object properties, they get a little even trickier. But at this point, just a plain graph. So we didn't need a data-driven way to decide what close enough means. If we just pick something arbitrary that feels right, instead we need to look at the real subclass pairs to find a threshold that matches the data. So that's why we took like means and percentiles. over like a corpus of similarity metrics. We wanted to see what on average is right. Now we trained our model on that co-occurrence matrix from the artifact ontology, and in training we determined whether our model could recognize subclass pairs that we kept separate from the training. This is essentially us checking whether learned patterns generalize beyond what the model saw. And what we saw in that visualization is essentially something that looks like if I had to draw a single line through this cloud of points that captures the biggest differences between them, which direction should that line go? What this means is, so I essentially was like, hey, look at this, look at the results of this model, this analysis, and I want you to like draw out the biggest differences, like find some feature that draws out the biggest differences for the x-axis and y-axis so I can see like properly distribute or clearly distribute in a two-dimensional space what sort of, if any, clustering is happening. So I wanted these things to be as far apart as they could be.
Clusters of vectors.
That's right. So that line, one of those, the most difference, like the biggest differences became the x-axis, second biggest came the y-axis. And this is what I came up with. Now I'll note I just ran this is even more interesting. I just ran this again. I'll pull up the results I got in a second to contrast with this because they shouldn't be the same. I'll explain to you why in a second, but I do want to point out this is what I ran last night. Got artifact ontology, 577 classes, 564 subclass edges, roughly one edge per class. Again, thinking about subclass of most nodes sit in small trees under the handful of root categories, just 3. See here. Each point is a class because the artifact ontology is essentially based a few big hierarchies. We're thinking about the subclass of the reduction strategy used in a script, collapsed it into those differences, just those 3 groups. And then within each cluster, those nodes are locally similar because they shared subclass chains and co-occurrence context. So you see things like artifact function clustering, material copy of barcode clustering, information artifacts clustering. Think about this. You were just looking at the artifact ontology. I'm telling you this analysis resulted in a bunch of hierarchy clustering. That should sound weird because I was just looking at RDFS subclass, right? Aren't they all related through entity? It didn't just look at the bolded classes. How did clustering happen? How did clustering happen? What do you think?
I found, like, I guess within everything that's in entity, they were further able to look at those classes and see like which types of entities are closer to one another. And then I guess like gradually they could get deeper into that, like.
So it is frame. It is true that entities connected to everything, but not directly. So
That's
it is
true.
far away. It is far away.
Mhm,
So it would not be. Well, if you have a flat ontology with just entity, of course, like that would be a super like heavy node. But here there must be something a bit below. I'd be surprised to see like barcode. I don't know, it's like how many things are connected to barcode. Maybe there are many many subclasses there. I don't remember. And also it's like it should be a material copy. Okay. Because like we all know that material artifact has a lot of subclasses.
Absolutely.
That's huge parent.
Let's just look over here. I said it
But
probably.
Geometrically, it's like seeing, let's say the.
Let's see what I got here.
Right?
Observe these. Material copy, sensor. We've got some more functions. We got rectifier units. So I just ran this again right now in front of you, and I'm gonna wager that I didn't get the same results. I did this a couple of times last night just for the lesson. I wanted to highlight something.
Yeah.
But there are two things going on at least. One is, and you should be confused. It's no. One is that even though there is the kind of bigger hierarchy, everything's connected to entity, there's like BFO step per level. You're right. Hops were certain numbers, like within 3 hops, these things were prioritized, and then there were random walks going through. And so we generated basically a similarity matrix, a co-occurrence matrix, a similarity or cosine similarity with it, and all this stuff off these random walks with like emphasizing certain numbers of hops within 3.
And we didn't use any descriptions, by the way, it's just the structure.
That's right, just the subclass of and like that. And that's one thing. And then couple that with the fact that the subclass hierarchy is united basically under one, like a mono hierarchy, like it's like a single directed graph, right? So if you're cutting things from it that are not on the leaves, you're going to create like siloed branches. And so you're going to have clustering. So if you couple those two things, random walks are only going to be prioritizing up to 3 hops, and you have cuts in the graph from a subclass of, because you're only dealing with subclass of, you should expect clustering of some sort. Turns out that the way the code is written, you'll end up with clustering in 3, and you should get, as predicted, different clusters when you run it because the random walks and whatnot are random over the graph.
So is the point that clustering happened because the way that the script works, it's like not actually the case that everything is a subclass of entity because there's like missing links?
Yes, so when we have our training set, which is subclass, right? And then we have to pull out, we pulled out like 10% for the validation, 10% for the testing. And so it's a pretty well worked out mono hierarchy, right? And if we're pulling randomly,
Yeah.
bound to get something that creates like little islands, right? And so that's what's going on. As we're doing our testing and validation, we're just gonna kind of have to create, it looks like. Now, how can we avoid this? How can we approach this problem? How can we avoid clustering of this sort that doesn't seem legitimate? I mean, I think I know the answer. It's going to involve something other than subclass of relationships, for sure. Also, the logical structure that connects hierarchies to other hierarchies that we'll see in object properties. I picked the subclass of relationship on purpose to kind of highlight that. Traditional embeddings are good at grouping siblings and pattern repeated subtrees. Look, this is not exactly a bad result, right? Like there's value here. Traditional embeddings are bad though at retrieving held out entailments that you and I know should be there. Like especially if the training graph is sparse and edge removal just breaks or creates these kind of islands. And the artifact ontology is one of these kind of setups. It's bushy in places, but kind of globally sparse. Yeah.
The randomization basically made this cluster. So if you rerun the algorithm, you will see other clusters.
Should get others.
And,
yeah.
I wonder why 3, to be fair, because the 80-10-10 split. So this should reflect actually what we have in the training set only.
Mm-hmm.
Of course, we don't know like how
Yeah.
split works.
Dig in the code.
You can inspect it, of course.
Dig in the code. Yeah. But note too, this other follows the validation scores when you run it cluster around 0. And that's because our parent-child pairs stop co-occurring in training walks because it was too sparse. Even so, nearest neighbors, they still intuitively look like, I mean, this is what I mean, like, it's not like the worst result ever. The distribution hypothesis is still on display. It's just like we got some odd results because of our narrow focus.
Yeah, it is always a bit dodgy, these embeddings, because you can also just start from the top of the hierarchy to anchor it a bit.
That's right.
But then you go fiddling with hyperparameters like how much anchoring versus how much clustering locally, and yeah, this is that part of machine learning that I've been there so many times, and let's put it this way: the knowledge you gain
Mhm.
is 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 semi knowledge. I don't know how to I think I expressed it reasonably well in Slack. I mean,
Uh,
now for machine learning, you have special commissions in the financial industry to decide what is allowed or not. You don't have that for logic, you know?
yeah, right.
It's that thing. So
That's
you're
what we need.
doing,
Yeah.
yeah, no, but so
So
you're
we need
doing,
us. Yeah.
yeah, but so you're doing something,
Mhm.
and it's all very, yeah, subjective, and that can cause all kinds of interpretation problems. So you do something, and then you still need a committee to decide over what you have done. And I mean, it's like that's not how knowledge is supposed to work. Yeah,
No,
sorry, this is sort of a meta thing, but
no, I get it. I
is
get
it a
it.
fair point?
It is absolutely a fair point. Absolutely.
Okay.
And so this highlights, I think, and I'm not saying that I'm not about to say that MOWL is going to solve these problems because it's not. But I am going to say that it's designed, like the people who have been developing it are designing it with these sorts of issues in mind, so we can build in not so we can get rid of the committees. I was thinking they think you're going to get rid of the committees yet, but we can get rid of some. We can take some of the tasking off the committees' backs because a lot of people agree with basic logic, like basic formality, basic structural principles. Now, how do you kind of extract those things that we agree on? And this is where I think MAL is pushing in the direction. Now, again, I remember the first demo of MAL was at ICBO in 2022, and I was like, I'm so glad somebody's doing this because I've been thinking about this for a while. I'm so glad. And they had some interesting results. There's still a long way to go. But as I understand, it's the best game in town we're trying to build in, at least for OWL ontologies. These kind of make this connection to fill in that gap using these EL embeddings and interpreting the ontology's axioms as constraints. Each class here represented as a region, subclass, and restriction axioms shape how the regions must overlap. Okay, that's all hat from last time. That said, garbage in, garbage out, right? Garbage in, garbage out, even with MAL.
The algorithm that we
Mhm.
have seen on CCO used on CCO basically is a k-nearest neighbor algorithm.
Yeah.
Okay, so and MOWL does a completely different thing because last time we just saw it like running. We didn't like open under the hood.
That's right. That's right.
It was under it.
Yeah. And there are many other strategies. You can like tinker with the word effect to get different results, but the end, you're still going to be missing what we're talking about, like we want to put something the logic, right? We want to be able to embed that.
And right now we just use NLP.
That's right.
With the vector semantics, as they call it.
Vectorized semantics. So what we want to do is learn that logic and predict it. We need to feed it the appropriate amount of data for the logic to we want to learn it from embedding the inference patterns directly themselves. So yeah. Now that is where we come back to where we left off. All right, I want to tell you about this project. Wow. Project 5. I got some learning objectives here. So you're going to use machine learning to discover missing logical axioms in Common Core Ontologies, specifically in the artifact ontology. One of you, somebody else will do the information artifact ontology. Somebody else will do units of measure. Somebody else will do this, and that. So there are 11. I think everybody can do one. If not, I'll give you a different one. I'll give you IES or something. IES will be a great example because it has no axioms. While CCO's textual definitions contain rich semantics, most logical structure is still implicit. Your task is to use MOWL semantic modeling to make that structure explicit with no manual intervention. Minimal manual intervention. I'm an optimist. Each student will select exactly one from the 11 modules, train a MOWL model on its existing axioms, generate new candidate axioms from textual definitions. MOWL is restricted to the EL profile. So you can't train on any like it's like its sophisticated cardinalities are going to be out of scope. Still, you can capture things like subclass of some existential restrictions, disjointness, and like chains of subclass restrictions. are chains of subclass existential subclass restrictions. You can generate these from the textual definitions, and I hope you do. You'll then use MOWL to filter those candidates by learn semantic similarity and then merge the enriched ontologies together. So you'll build the axioms, auto-populate according to your threshold, make predictions about what axioms should exist from the textual definitions, and then you will add those axioms straightforwardly into the CCO module, and then you'll run a reasoner to see if it's consistent. Students should coordinate, so no two students are using the same module for this project. We'll each get one. Again, if we run out, if more than 11 people want to run on this, play with this, I'll give you another. You can use IES. The outcomes here, I want you to understand how symbolic and learning neural models can support ontology engineering. Obviously. I want you to learn how to use MOWL to train embeddings over this L2 profile. I want you to combine MOWL similarity for axiom filtering and then validate the ontology quality and consistency using robot and elk. That last thing you're already pretty familiar with at this point. You could just call elk if you're not familiar, just like you called Herman and robot, you just call elk. So that shouldn't be novel. Now, in a little more detail, you will choose a model. You will extract textual definitions from that module into a CSV file. You probably already have a script that does that. In a previous exercise, I had you extract definitions, like from an ontology. Just use you can use the same script. You can use because this project is linked up to a large language model, so it's not due until later. I actually put it off another week, so you have like an extra week to finish this project. I will be talking about using LLMs next time. So you'll have some space to get to the LLM portions, but I will encourage you strongly to use LLMs to rewrite, normalize, and generate some OWL2 EL compliant candidate axioms from the CSV. So I know I had you a minute ago spelunking in the textual definitions and thinking, what logical structure is there? You will still need to do some of that. When I say use an LLM to rewrite, normalize, etc., these things are bad at logic. You will still need to look at it, but I encourage you to use them to help you do your spelunking rather than going through and like trying to think it through on your own. You'll need to think carefully about how to prompt it, how to evaluate it, because at the end of the day, you could, if you just start throwing prompts at it and say, hey, you just like copy paste this command and say, do this with a CSV file, you're probably going to get a lot of garbage. So you probably need to think carefully about how you prompt and engage with the LLM that you're playing with, so you can also have guardrails or at least be able to check what you're doing. If you just throw this command at the LLM, I have a feeling that you're going to end up having to spelunk each and every one of the definitions, maybe doubly, because now you have bad output to sieve through. You don't want to do that. So you might want to think about some patterns for how to structure your queries or prompts. That's it. After you've done something of those sorts, train a MOWL model on the existing axioms in your module to learn semantic embedding space. Why this step after the spelunking? Because CCO doesn't have that many axioms. If you just ran and started like training on the OWL axioms now with MOWL, you're not going to get much. There's not a lot of sophisticated logic. If you did this with BFO, pretty rich axiomatization. You're going to find in your life as an ontology engineer, not a lot of axioms. You don't want to have to go build those things. Try to come up with a way to help automate or semi-automate that. So in any event, we're going to need more richer semantic space so we can do training. Yeah.
Aren't we importing VFO as well?
Yeah. You will. But if you were just using VFO and doing prediction on that, I mean, you'd get pretty good predictions for just VFO, right?
Yeah, you get predictions within
that's right.
VFO.
Yeah. So I want you to train the MOWL model on the existing axioms in your module. So not the original CCO module, but the one you've extended with new axioms. Then filter candidates using MOWL cosine similarity, and then pick your poison an LLM plausibility matrix or plausibility score. Using an LLM to say, hey, does this make sense? Now, cosine similarity plus this for a reason, right? What I want to do is try to find, and this is part of the open-ended research here. I don't want to have to go through and look through painfully the axioms that are generated by MOWL and be like, good, bad, good, bad. My threshold's not, my similarity metrics, the threshold stuff's not going to be perfect. I don't want to have to go through that and do it manually. I want to use some other model that can look at them and give me kind of a plausibility score. And I want a combination of those two to help me filter in on what I should spend my time thumbs up and thumbs down in. Now, what that plausibility score looks like, it's up to you. How you use it, we'll talk about it next time. But I definitely don't want you to just generate a bunch of axioms, or I'm sorry, a bunch of like predictions that you have to filter through on your own. And I also don't want you just to say, give me something that says, hey, these predicted links were above the threshold, so like they're perfect. Don't do that. All right, I want you to automatically merge the accepted axioms that you have back in the module, and then automatically reason with elk over robot to check for consistency. And at the end of this, I want you to write a script that just runs it all in one pipeline. So previously I'd had you do things like run it through GitHub Actions, right? YAML, that's one way to do it. I wanted you to learn how to do that. You can also just write a script that fires everything off one after the other as if it were in a pipeline. For this case, I want you to do that. There's MOWL, practical uses. MOWL again, if you haven't installed it, make sure you set up work on project 5. If you are, for the rest of the class, make sure the other people are. So if you don't have MOWL set up, you should set it up. If you do have MOWL set up, let's make sure everybody has MOWL set up. Otherwise, get to work. You can see it on the repo. I pushed it last night. I also put the code that code I used on Collab up there if you want to run it yourself. It's under documentation. And you should have the artifact ontology in the repo too, but there's also a link. You can find it on the GitHub for Common Core Ontologies. And I will pull that up here. Let's see. Oops. Academy under Tradecraft. We talking right. Project 5. Everything I just described is right here. You'll see details, criteria. Also, you'll see a sparse project with just a README. You will be providing the repository structure along this line.
So I am way behind on this. I'm trying to set up the MOWL environment now. I'm looking for it, the link to it.
Cool. Do you run Windows?
Yeah.
Okay, got it. Is anybody running Linux? Because I sort of installed it, I think. I run Linux myself. Alex, you got it installed? Yeah, maybe not present.
So my background is not software at all. So
Got it.
this is a challenging course
Yeah,
for
yeah.
me. One of the reasons I'm still back in module 2, combination of time available and just
Yeah.
I think I'm beating myself up over stuff he's not quite looking for in this one, but yeah, I'm still behind.
Yeah. I also had just, so it is a bit of a hurdles. There's unexpected things happening, et cetera, et cetera, et cetera. So indeed, it's just it's not easy this because I'm actually writing software for 30 years, and I'm also sort of like, yeah, do what's what's up here, you know? So genuine respect for you doing this, as in, yeah, you know. Um,
So I was gonna propose I can definitely learn and I can absorb and ask questions and help, but like I was gonna ask if I could pair up with somebody, but I know he said he wanted this done individually for each of the modules.
yeah, yeah. Um,
Guys, if you haven't decided the module, I would like to take one.
Go ahead.
Event module.
The event module?
Yes.
Okay.
How
Had to
many?
make sure I heard that right.
11.
Maybe I'll make a thread in the Slack channel just so that in case people wanna.
We can grab things from IES.
There are enough modules to go around for people in the class.
I think
Yep.
so. If not,
Sam.
I can give you more.
Mhm.
There's IES would be the next one I thought of. In fact, if somebody just wants to volunteer for IES, you're welcome to volunteer for IES, Information Exchange Standard. That would be super helpful to me personally. I didn't want to impose that on you because it has like no axioms at all. And honestly, some of the textual definitions are, that spelunking we were doing a minute ago, like Fede was doing with resource, where it's like, uh-oh, this is problematic. You'll have to scrutinize IES for that. There's like some use mention confusion and stuff.
Yeah, Sam, I can help you sort of installing. I'm not a Windows guy, but I programmed a lot of Python, so I installed a lot of this shit. So
Yeah, installing and setup isn't so much of a problem. That's pretty
okay,
self-explanatory. I can get that stuff done. It's when you start getting into, I will spend hours on Stack Overflow because I did something
got it.
wrong trying to execute a workflow of some sort, and it
Got it.
just never worked.
Got
So
it. Got it. Do you use LLMs to program a bit, or
yeah, I have. I did a
okay?
couple things with LLMs. It found wrote a Python script to go scrape the web for ontologies. Well,
Yeah,
the LLM wrote it. I didn't.
yeah,
I ran it and made sure it worked.
yeah.
About it.
So I think sort of the general best advice on this is to say like you can just ask an LLM to write a script for you and it will basically work if you're precise enough in your wording. And the other thing is just to, if you can break it down yourself, the problem, like, hey, how do I get all that? Show me how I can read all the SCOS definitions from a file. Or step one, I want to identify all the classes. Step two, I want to get there. If you just break it down, it will sort of provide you with code that sort of helps and works, and that sort of helps a lot with sort of looking up all kinds of API calls that you otherwise wouldn't know that exist, because it's basically sort of an unknown problem. You're
Yeah.
looking at RDF lib and you don't even know what kind of questions to ask, to be honest. And I think LLMs can be very helpful in that, just to get you started. And in the end, you sort of find out, oh, I could have done it smarter. But then you're on your way, and then you already feel a bit comfortable. And the fact that you conclude that you can do it smarter means you already sort of learned. So it's sort of like, yeah, that's the advice I can give you.
It would be retired.
No, I just get frustrated searching through hours of Stack Overflow because I get some random error. Like I couldn't even set up my Python environment right because it kept giving me an error, I think because of a Jupyter Notebook version. And anyway, like
Yeah,
completely unrelated to
got it. Do you use
this.
PyEnv?
Do I use what?
PyEnv?
No, I don't even know. What is
Okay.
that?
I think it's worth, so it's, because what you're referring to is sort of a library version problem.
Yeah, correct.
And so with PyEnv, it's basically, yeah, let me translate this correctly. So Python is an interpreter. And
Yep.
you have sort of in your user account or global account, you have a Python interpreter installed. And that Python interpreter has some libraries. If you just start installing in your personal Python or your PC's Python, if you just keep on installing libraries, you're going to run into conflicts because some are newer, some are older, and this library uses this HTTP library, and that library uses an older version of that same. It gets a mess. So PyEnv is basically sort of trying to get you a clean Python instance that you can just install stuff in, and then you can also delete it, so that you always have a clean Python to start with. And that's with that you circumvent a lot of Python issues. So and it is something like, and I'm saying this by heart, you say sort of CD projects, go to projects, mkdir, or yeah, make directory project 5, but that will already have been done sort of by sorry, you will already from Git get a directory structure, and let's say you go to the top of the structure that John made here for the projects. You can say something like pyenv virtual env Python 3.10, and then you say sort of OTC Python. And then it creates a local Python for you for that project that's completely clean. And then you're going to have way less issues installing other stuff. And if at some point you find out, hey, my Python installation is giving me issues, then you just delete this pyenv and you make a new one and you start over. So that's the story on Python. Does it make sense?
No, it makes sense. How do you spell it? So we can get back to the
Yeah,
project.
it's PYENV.
Given. What we do is we check.
Got it.
So that it's definitely worth looking at. And you can also say something like pyenv space local, and then if you just made an OTC Python, then you say pyenv local OTC Python, and then every time you sort of go to that directory, it automatically selects that Python for you because it knows, oh, I'm in an OTC project. Now I need to, if Sam is asking for Python, I should give him the OTC Python with the libraries.
Okay.
So pyenv is really sort of the way to make everything run more smoothly because frankly, libraries and installing, whether it's DLLs or Java jars, it always gets a mess. So the more you can isolate it, the
The
better.
better. Okay.
Yeah, so that's one tip.
Thank you.
Yeah, and
Did anybody, what's the correct link for the MOWL?
Sorry?
The machine learning OWL, the environment you got to set up. What is the correct link for that?
The link?
Yeah.
I think, yeah, let me get it for you. Because it basically, because that's the second step. ML, GitHub.
Oh, yeah, it is in the Git. I was looking in the GitHub, but I don't see
Yeah.
the actual ML link. I see all the turtle and the train MOWL.py and all these different file names that John put in there.
Oh, sorry. Yeah, I just flagged you the repository for ML
Okay.
itself.
Got it.
Just to for information, because you can just read it. This is what I did, and it basically worked. Now there's one caveat, or two, and the one is use pyenv, to pip, because do you know pip?
I've used it. I really don't understand how it works, but yes, so I
Okay,
use it's like pip install, pip do this, pip do that,
yeah.
but I don't know what it
It's a
does.
package manager. So
Ah, okay.
basically, pip install means install this library. You can sort of say download a jar. You can say sort of install a DLL. Yeah, pip installs Python code in your interpreter, sort of, because your interpreter has a folder structure with libraries. And this basically says, I'm going to take the MOWL Borg package, ram it on the interpreter, and that should be your PyEnv, clean interpreter. And then it should basically work.
And the
And
interpreter is whatever you choose to use, whether it be VS Code or Anaconda or Jupyter Notebooks.
yeah, well, interpreter is really Python, but then your IDE, and that's sort
Okay,
of your development environment, can be VS Code. Absolutely.
got it. So the interpreter is different than IDE.
Yeah,
IDE is how you interact. Interpreter is the software, for lack
yeah,
of a better term,
yeah. That runs the
or the
code
code that
basically.
runs.
Yeah,
Yeah.
it reads the code, and like a machine starts interpreting, and then step by step by step, it sort of starts running it. And if you do, you have VS Code installed or not?
Yeah, yeah. I got VS
Yeah,
Code installed.
because I think there you can also, then it's probably easier to Google sort of like, hey, how do I make a virtual environment using VS Code? And it's just 3 or 4 clicks.
Yep.
And it's basically going to install that Python interpreter in your project directory. So in the directories that with git clone you downloaded, and it's going to ram a Python installation, a clean one in it. And when you run pip, it's then going to download those packages and put that in that installation, not in the global installation, not in your personal installation. Because, yeah, if you keep on installing packages upon packages, it is going to break at some point, for sure.
They would
Uh,
just.
Okay. I don't want to take this
yeah,
whole thing up talking about the basics of software stuff. So if people have
yeah, no,
questions
no,
about the
but
projects,
yeah, no, I mean, what you want. Yeah, last thing I can say is that Jupyter is actually yet another package, and
yeah.
it will install it for you, and then it will run. So,
Yeah.
okay. Um, yeah, let me first download it myself, and because I didn't get Project 5 yet. Yeah, all right. I got it checked out, and basically, yeah, there's this README. Um, what would you like to do, Sam? Would you like start programming or just run through it? Sort of, what does it even mean? Because that first
No,
step to.
we can start programming. Yeah, we can start programming.
Okay. Okay, okay, then I'm gonna pick a CCO module.
Oh, is MOWL only on Linux and Mac?
Nah, don't.
The
Yeah.
the the link that Mike B just put in.
Yeah, that's what the documentation says. You might have some incompatibilities if you're running it on Windows because of Java.
Okay.
Oh, wow.
I guess I will have to install Linux.
That's a lot of work.
Yeah.
You do have Windows subsystem, huh?
Probably. In the past, I've installed a Windows environment on a Mac computer. Oh, I haven't done that in quite a while, so I've done it something similar before. I just need to sit down and do it.
Okay.
Right.
Yeah, there is a Linux subsystem for Windows. You can just install it with one click, and then you have sort of a Linux environment on
Okay.
in your Windows. But there are some rules of the game, and I'm not familiar with them. But in general, I hear sort of good things about it. Let's put it that way.
Okay.
And yeah, I'll look it up for you. Maybe you can start with that,
No,
then
I
you
already
don't need
started
to.
looking it up. Mike put
Okay.
something in the chat. I'm good.
Oh yeah, WSL. Yeah.
Yep.
Yeah, I think the default that it does is Ubuntu, but if you want to do a different flavor, I think there's a bunch of other ones you could install.
Yeah.
So
Ubuntu is ubiquitous. It's the largest, almost the largest, I think.
Yeah, I will
Largest.
stick with Ubuntu.
Yeah.
Stick with the largest, most well supported for now.
Yeah.
they cutting some things out.
Yeah, and one of the things then that I discovered last week is if you install WSL and then you try to pip install MOWL, then John said last week, like, yeah, see if you can get the module version. But I banged it for 5 hours, and that module version does not appear. What does work though is just basic scripts running some MOWL functionality. So don't get. I think it's getting focused on printing that version number might cost you a lot of hours. And I put in the chat a little script that just does some simple stuff, and it's like 5, 6 lines. So maybe that's smarter to test your installation with that instead of trying to print the model version.
Okay. Well, the Pi ENV is no longer being maintained on VS Code anyway.
Which that comes from.
Okay.
Let's see. I can figure it out. Let's
Yeah.
see.
There is different. I mean, there is different. There is Pi ENV. There is poetry, but that's a bit more complicated. There is UV, and these all support this kind of sort of. Yeah, and I think if I hear what you're doing, I would look up a Python tutorial with WSL under VS Code. You should get a page that says install WSL, open VS Code, sort of connect to WSL in this way, and then sort of create your virtual environment that way. So I expect that you should be able to get one web page that walks you through the whole process to get this right, to be honest. Because I think if you try to figure it out by yourself, it can take hours.
Yep.
And this should be sort of a normal route to follow. Let's put it that way. It's a pretty normal. Let me check it myself. Yeah, there's a lot of pages saying this, and there is also perhaps a video. Yeah, from 2020, a bit old, but yeah, perhaps it will still work. There's videos and web pages all over the place.
Okay.
So I would specifically look for that combination. Otherwise, yeah, if you try to do it yourself, hours, man, hours.
That would make it quick for me.
There are a bunch of videos, I think. Better yeah, that you can learn from. Greg was explaining he thinks he's a visual learner, so he needs to see the training and test. I get it, me too. More of a visual learner, I like pictures. You guys sound like you were doing some heavy duty debugging or some wise sage advice as to how or when to avoid debugging and when to just
Yeah.
Yeah.
No question. I think MOWL and Windows might not be best buddies.
Oh, is that right?
Right? So we're sort of talking like, hey, how to develop under WSL, Windows subsystem for Linux. So then you need to, no, just say. So that's why I'm asking, sort of. But I think VS Code, WSL, they work pretty good together. So I think once you have it set up, it should work. But it's extra work.
Yeah, that's fair.
This is
So
an option.
I'm playing on the Mac, so I didn't even see that.
Yeah.
Believe it. I'm not. I suppose I shouldn't be surprised.
Yeah. Yeah.
I'm gonna reach out to Robert though after this and be like, "Hey, man, like we're trying to use MOWL, but you're not making it easy."
There
wanna
was a
see-
README with all the descriptions on how making the virtual environment, and I made it, but I don't find this README anymore.
There was a readme, I gave lectures.
On the virtual environment in which we have to run MOWL.
Yeah, I'd given it
And,
in a PowerPoint.
Where is it? It was on a PowerPoint.
Yeah, it was in a
It
PowerPoint.
was
I can
PowerPoint.
put the PowerPoint.
Yeah. Want to run the toy sample?
Yeah, yeah.
first?
Here, I'll
I really had a.
I mean,
Yeah. So, John, would it be an idea next time we give this course to have these projects in different projects? Because I spend quite some time and risk sort of, oh, this is overwriting that now, that's overwriting that now. And I know it's me not thinking that structured about it, but I'm also not used in multi-projects within one repo. I always keep it as small as possible because Git is already pretty complicated.
Right.
And
We
No,
can
it's-
make multiple branches.
yeah,
Produce that.
yeah, that's fair. I see the value of doing that. I may even just try to. I mean, collab is a nice environment. Like, I may just
absolutely.
look over there and like have projects done that way that we don't. I mean, there is some value, and that was motivating some of my thinking. There was some value in like having folks struggle who haven't done it before, who that struggle before with like learning in a sense the hard way. But I think I may have overestimated or underestimated how time consuming that might be, even for folks who have done this before. And so, yeah, I'm hearing what you're saying. I think I'm going to change this next time for sure.
Because then every time you have sort of a clean slate and you're not being held back by the craft of earlier things. Because that's what I see happening a bit with myself, sort of. But again, it's my own lack of
like
system.
it's like there's some things I wanted to like ideas or skills I wanted to instill. That's not obvious. That's not obvious to me that was one I needed to. So that's why I'm like open to revising. This is the first time I've taught this class, so any comments, concerns, criticism, compliments, welcome. So, it will certainly change. Never perfect the first go around. I'm sorry you guys are somewhat guinea pigs. But I'm happy you're so game for it. Well, everybody, ladies and gentlemen, we're going to bring this one to a close. Barry and I are going to get set up to debate. You're more than welcome to join us for the follow-up session. It should be a lot of fun, as was last time. If you have any questions, concerns, etc., reach out. But yeah, Project 5 up and ready to go. Go learn some machine learning. All right, take care.
Cool. Thank you, John.